Greetings and welcome to this episode of Let's Create Something with Trapcode TAO. And today we're gonna look at how to recreate this little thing I made a while ago. And I would say it was inspired by, I don't know if you've ever seen one of those at one of your friend's country house, but you know those kind of what I like to call sunburst mirrors. And I suspect those are inspired from the depictions of Aureolas that you always see crowning the heads of many religious characters in Baroque and medieval paintings. And I think this Jesus Sacred Heart was painted by Joel Roger Espinosa Camoro. It's this guy, nice shirt, and he's from Peru. So that is a little train of thoughts that led to the inspiration for that particular design. So it's just a reminder that inspiration can be really random and can be found anywhere. So let's hop in After Effects, and the main goal of today will be to look at how we can control the fractal displacement on only certain areas of our 3D object. So let's start by creating a new composition, Control N, and let's make it 1080 by 1080 on 720 frames, and we're gonna call this Sunburst. And let's create a new solid, Control Y, let's call this one Tau, and we're gonna apply our beloved effect, Trapcode TAO. Right, before we start, let me show you how we're not going to do this. So just as the sake of exploring another avenue here, one way to distribute sticks around a circle with our automatically generated circle path would be to select repeat n-gons instead of extruding them, and maybe have them smaller and make them cubic and stretch them on one of the axes there, and make it thinner on the other one. And the amount of segments would control how many sticks that we do have, and we can control the radius with the size value here. But we're not going to do it this way, because what we actually want, let me show you from the wireframe point of view. So we get very few segments, like only one segment by n-gon, so we won't be able to distort this in the correct manner if we increase the amplitude of our fractal displacement. So we're not going to do it this way. We want to generate our stick. We want it to have many segments on it so we can distort it as we want. So let's reset that and let's start from scratch. And instead of creating a circle, we're going to create a line. So let's choose line. And first of all, we're going to center it out. So our comp is 1080 by 1080. So half of that is 540. So let's put that right in the middle. And for the line point 2 y value, we're going to drag it negatively for it to go upwards. So that's going to be one of our stick, which we're going to repeat. And on this one, if we look at on the wireframes there, let's make it black. So this is the kind of geometry that we're gonna have here. Let's increase the number of sides so we make it more like a cylinder, and let's uncheck the chamfer. So this is the amount of geometry that we're gonna have to distort as we want. Let's make this smaller, and we can even add more segments to get more details. And let's shut off the wireframe, so this was only for us to see. And maybe we can also set the shader to smooth here. And one last thing there, to uncheck the break side. So we'll make it our cylindric rod here, which start from the middle point and go upwards. And to distribute it in a circular fashion, we're going to use the repeater. So let's twirl down the repeat path section here, and on the first repeater, first off, we're going to uncheck the arrow on symmetric double here, and also we're going to set the world position X to 0. And let's start by looking at what it does. So now we have one stick and we have 0 repetition. So 0 counts as 1. So if we have 1 there and rotate on Z, so we have 1 there and we have 2. So let's try to remember that. if we would want more around like this, and let's try to think about this logically. So how would we set this up so we can decide how many sticks we want and have the correct angle of rotation here automatically? So let's look at it mathematically. If we would want to have, for example, 62 sticks, the angle value we would want on rotate Z would be something like 360, which is a full circle, divided by 62 plus 1, so 63. And that'll repeat it correctly. So if I was to remove 1, 62, there we're missing 1. So now we have the exact same amount of space in between each. And let's push that even further. So let's link both these values together, so we only have to change one and the other changes accordingly. So let's alt click on the stopwatch here for the R1 world rotate Z, and let's say 360 divided by, open parentheses, let's use our pick whip here and select our number of repetition, so 62 plus 1, and close the parentheses. So now if I were to put any value here, so 50, 34, it'll put the right value here accordingly automatically for us. So that's pretty cool. One more little thing though, if I was to drag this value here, if I end up having a non-integral number here, so it's 37.7, it's gonna have an uneven space here. So I want to prevent that right in the code. How can we do this? Well, I hope this is not too advanced, but let's look at a mathematical function we can use to round it up downwards, so towards the floor, not towards the ceiling. So let's go right before the effect word here, and let's click on our little arrow here and go on the JavaScript math. So here we got a lot of functions here, and the one we're going to use is math floor value. So let's click on here, and it's going to write it down for us. So now we've got the word value here in between parentheses, and we're going to go and select the effect TAO repetition there all the way up before the plus sign, and we're going to cut that, Control X, and we're going to replace the word value with that. So now it's going to round it up. It's going to prevent us to use the fraction number, the decimal number here, so we can drag this number now, and it's going to behave accordingly without any uneven space one. So that's pretty fabulous, isn't it? All right, so now they're all starting from the center point, and let's have a hole in the middle. So in order to do that, we're going to grab our line point 1 y value and drag it negatively. So instead, if we didn't have any repetition there, still back with one stick here, instead of starting from the middle, it's just gonna start a little upwards there. So if we're to repeat them afterwards, it's gonna make a hole in the middle, right? All right, so basically we have our circular display now. We can increase the fractal displacement, and it's going to behave a little bit more like we want to in terms of distortion. We're still going to get it tapered down here, but that's how the fractal displacement works. One thing that we want to do though is we want to pinch it near the center there, so it's not distorted. We want to control the amount of displacement that we have along our path. So how we're going to do that, since we're using the line automatically generated path, we don't have anything to keyframe aside from right in the offset here and the offset animation sequence, which we're going to activate there. And we're going to play around with the OAS fractal. So this is going to help us designate exactly where we want the displacement to occur. So let's look at it this way. The OS duration is 10 seconds by default. So 10 seconds is 300 frames. At frame 300, it'll be the last frame play with our geometry there. So let's add a keyframe there. So last frame. And let's hit on the stopwatch here for the OS fractal, and let's hit U so we can reveal only that, and let's bring it all the way to the beginning, and let's create another one. So at the value of 100, and let's create one in the middle. All right. So let's get back to the beginning, and let's set this one to 0. So look at what happens. We have it pinched at the center now. Our rod, cylindric rod, is being drawn for like the duration of this in the timeline. So if we drag this, like this is the section in between frame 0 and this keyframe is equivalent to this section here of our path. So here we don't have the fractal, and it starts to get displaced from right about this area and right until the end. So if we want to keep it at 100 for a little while here, and then bring it down to 0 in order to have them pinched on the tip as well, right? So let's increase the fractal displacement here. So as we control these keyframes here, we can decide how close to the circle it gets pinched, and also we can ease them. So right click keyframe assistant, easy ease, so we'll get somewhat of a smoother transition here. And let's bring this back. Let's also ease those. Right click keyframe assistant, I meant to do easy ease, and I'm not hitting F9 because it stops the recording on my software. So yeah, that's how we quickly displace the path, and we can of course change the frequency in the oct scale. This will alter the displacement scheme, so this will have a wider displacement, and this, as I increase this, it'll get tinier and tinier. So I want to get something around 1.5 here. 1.5 is good. And let's animate this. So in order to animate that, let's make it 90 frames. So let's see here. We can animate the offset X, which is gonna make it flow horizontally. So let's go to frame 90 and let's increase this value. So we've got to increase it enough so our loop is making sense here. So let's try 850 to start here, and we have both our keyframes here for the offset X that goes up until frame 90. And if we look at that now, it's gonna flow like this, and it's not gonna occur near the center, but it's not gonna loop here. Our last frame and our first frame are not the same. In order to make it loop, it's might be a little unintuitive at first, but it's quite simple system to make it loop here. Now that I've keyframed the offset X, and these here, they shouldn't even have stopwatch, because usually we don't want to keyframe those in the seamless loop section here. We just want to click here. We just want to go here where we have our last frame here that is set as 850 in this case, and we're gonna click here. It's gonna just populate this value in there, whatever the difference between the first and the last keyframe that we have. It's gonna make the math and put the right value here for us. So now the first frame and the last frame are exactly the same. So if we were to RAM preview that, it would be seamlessly looping. But you gotta put a value that's high enough here. So let me show you what would happen if, for instance, we didn't have enough of a high value here. So 200 here. You can see here how it looks. I mean, you can see that there are obviously something wrong in there. It doesn't have enough to go on to make it look correctly. So we want to make sure that this value is high enough. And now that we've set the end frame here, is still gonna not look right until we click back again. So 546 here, really arbitrary value, and let's test it out. It works fine, so that's good. That's good enough for me. And what I like to do here in Trapcode TAO with the fractal displacement is animate another axis. So here on the Y here, we can also animate it and put a smaller value here, but always make sure that it's high enough for it to look correctly, and click on the end frame. So it's going to put down the value here as well. So that makes it in let's increase it a little bit more here. So that'll make it a little bit more detailed, because we could just animate the evolution and animate all three axes simultaneously. But now that we get a different velocity of motion on the X and the Y, it's gonna maybe give us a more interesting movement here. And we can use our evolution value as a simple seed random generator. So if we're not happy with the result here, we can always tweak this unkeyframed value here to scramble things up here in our setup. So right, let's create a camera. Control Alt Shift C, and let's make it 50 millimeter, the default. Let's click OK. We're gonna make it a little dolly for absolutely no reason with a null. Control Alt Shift Y. We're gonna make it 3D and attach it with our pick whip, and then we're gonna hit C until we have this pan camera tool, and we're gonna pull back a little so we can have a more global view of our object. And also we can rotate to see how high it goes in terms of and displacement here. We can simply adjust that if we want it to go higher. So let's get in the fractal displacement there, and maybe increase the amplitude, or you have this section here, which is individual amp and freq. I won't get in too deep in details with that for now, but this should give you an idea. If you want only to constrain it on the amplitude on the Z, for instance, or on any of the axis, or for the frequency here, we have settings that allow us to manage those separately in here, allowing us to get more variations as we see fit. So let's get back to this view, and let's look at our animation. And maybe the fractal OS is not 0 at the end, it's 9. Let's maybe have it halfway, so it's not completely pinched on the tip. They are still moving, but not as much as in the middle of the path there. So there's a fun, cool way to have something like, and let's increase the distance between those keyframes here. So as you can see, we get a more gradual transition. All right, so this is our basic setup. There's many things we can do playing with that. Secondly, what we're gonna look at is how to make it look a little bit better. So you can stop right here if you've got the principle, and that's only what you seek to learn. But let's push it a little further. So second part is we're going to work on the looks, and the third part we're gonna make it gonna use expressions to make it a little bit more advanced. So bear with me, stay there. We're gonna have fun. We're gonna make this look even better, and learn a few things along the way. So let's make it seem a little bit more of a metallic material. So let's get down in the material and lighting, and let's get in image-based lighting. I like to use the dark industrial pre-built environment, and almost by default we get something that looks nice in terms of metallic thing. And maybe we can increase the details here in the multi-sample, set it down to 16. We'll get a little bit less noise in there. So let's increase the amount of reflection, even set that even higher. We can increase the metal value here, but I don't think it's gonna change much. And so right now it looks pretty fine, aside from the fact that we get some dirtiness here in the reflections, because all the highlights on the image used for this are really sharp, and it's not, we would want to use the same HDRI, but we want it more blurred. So one thing that's interesting with the collection here is that we can get the HDRI images that are used in the pre-built environments for Trapcode TAO. We can get these images as EXR. You can get those from the Red Giant website. So I'll put down the link in the description below. And here we have the industrial room. We don't have the dark here because the pre-built only uses the same image here, but only toned really dark. So let's drag this, let's import this image here. And what we're gonna do is simply use the same reflection, but we're gonna blur it a little. So first thing, we're gonna make a comp with that. And since we're in 32 bits, it's gonna be pretty big. So maybe it's gonna make it a little bit difficult for me to work in real time there. Maybe I should set down the resolution a little bit. But first we're gonna use the curves to tone it down and make only the highlight pop. So let's do something like that. So now we're getting approximately how I think the image has been doctored to give this kind of result in the dark version of this industrial room. But right here we can see here that it's the sharp areas here between these contrast spots that makes it a little noisy and everything. So we're gonna use the fast blur, the new fast box blur here, to blur our reflections a little bit. So if we do that, we are not going to get something that so did I move the image? I think I moved it. Alright, so here we're getting something that we have the highlights there, but there's not as sharp as in the pre-built version. So do you follow me? Let's call this ref, and we're also going to make our diffusion map with that. So ideally this thing can be real small, so let's make it 400 by 200, and let's hit Control Alt F to resize our image, and let's add even more blur on this one. Always repeat the edge pixels. Did I do it on this instance? Yes. So let's get back ref2. This is not going to be called ref2, is going to be called diffuse. And let's get back in our Sunburst comp, and let's bring both of these right in there and shut them off. So let's save that for the moment. And let's get back on our material and lighting right in the image based lighting, and instead of the built-in, we're going to turn it off for the moment. And let's make sure that this checkbox is active here. And for the reflection environment map, we're going to use our own custom reflection map. So right now we have the metallic look, but it's not as noisy as it was before. And let's use our diffusion map here, so we get a little bit brighter maybe. And maybe you want to pump in the reflection back in. So if you can, it's not yet perfect. I mean, we're not using a true legit 3D software here, but it's kind of better than what we have if we use the one by default. And I think you can notice that it's about the same reflection. We can change the angle of this reflection by rotating the environment. Let's keep it down to 0. And for the segments, where are my segments? Let's bring it down to 6. There. Have it a little bit tinier rods. And then maybe we can set this to super sample. Not get it entirely perfect, but much better results in terms of rendering quality. increase the reflection strength even more. Let's crank it up. So that looks metallic, and it's not that too noisy. We can always increase the amount of segments if we should get a little bit more detail in there, but there's always a limit to good things. So now, if we look at that, we have our flowing rods that are doing their thing there. It's running a little bit slow. And one last thing we can do with, let's get down to the shader, and right on the ambient occlusion here. So the width of our rods are 6 compared to 100, which is the default. So let's try to put the same ratio here. So 0.2. So we're gonna get back some of the details, and let's increase the intensity, so just can have a better look at it. And now we are bleeding in a little bit more shadows in there, so that's quite interesting. So that's the basic setup. Now let's push it even further. Now we're distorting each of these pieces with the displacement, fractal displacement built in there. And let's set it off to 0 for the moment. But what if we want to add our own little waviness in there as it's getting drawn? So let's try to do something here. What we're gonna do is, in the offset animation sequence, like we have the position X for our thing, which moves it left or right. But let's see, we can go and fetch some script there from Dan Ebert frequency. I'm gonna put it down in the description below, but let's get on this page here and let's look at a script here, which is fairly simple. There, let's copy that. I'm gonna put it down in the description below. Don't worry. And let's all click on the stopwatch for the OAS world position X, and let's paste that in here. And by default we should get something like that because the amplitude is quite strong. Let's set the amplitude down to 10. So that's what we're getting now. We're using this little mathematical function here to create a sinusoidal, I don't have a lot of trouble with this word, sinusoidal, anyway, sinus, cosinus, you know, those things. So we can have it waving like such, and the frequency will control the amount of waves that we have there. So this is something that would look perhaps even nicer if I were to add back the fractal displacement. So let's set it back, and there we have something that looks like kind of like that. I'm gonna set down the amount of segments just for the sake of the previewing this. So 300, and let's try it with 60, and let's try to put 8 only for the amount of size. Can I view this faster? Now it's gonna be a little bit slower with our custom reflection. So for the sake of this tutorial, I showed how to get better details, but let's set it back to the default dark industrial. And I do like how it looks. I just would hope it would be a little less harsh on the details here, but there's something that looks quite nice. Now we're almost done. I mean, we could be done with that here, and we could say that, all right, this is good, we're over with this, but let's push it even further. Let's animate. What if we were to animate this waviness here? So let's shut down the fractal displacement so we can see what's going on. And now we're kind of locked in our situation because we're not using a TAO custom light to build our geometry, we're using the line. So if we want to keyframe the offset, like we're gonna be stuck with the fact that our OAS fractal is keyframing there. So we want to separate the two. I don't know if you understand, but everything that is in offset animation sequence will offset if we play around with this. So this is, we're gonna lose our waves. Maybe if we make it loop. So is it gonna change it? No. Oh, it's, I thought that it would unpinch the thing there if I were to. So it seems that we're okay as long as we don't have the offset position checked in, which would, in this case, I think, affect how it's being pinched. No, I really thought it would offset the thing there, but I was mistaken. So let's see, now it's completely static. Let's create a keyframe on the offset at frame 0 on the start, and let's go at frame 90, and let's try to find our value. So let's put it at 100, and let's see what we get with that. So it's gonna go choo 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 choo. But of course it's gonna repeat, like we don't need all that. We just need one part of this loop. So let's grab a picture at the first frame and let's advance until we get the same frame back again. So I'm gonna move forward by hitting page down, and once in a while I'm gonna hit F8 to look at the reference frame, and I want to be back at the same, so right here at frame 18, right there, it's the same frame. So offset, this is the value 20, so we can fairly say that if we move the offset from 0 to 20, then we're gonna have a loop of this going. So it's gonna loop like such, which can be a pretty interesting thing. And then we can back on that, add the fractal amplitude. And yeah, that's where it's gonna get tricky, because it's also gonna offset the OAS fractal now that it didn't affect it before because it was at 0, obviously, but now we're playing with some keyframes and it moves the pinched area, so it doesn't, our loop will not function correctly with setting it like that. So let me show you the workaround for that. We want to separate both of these. We want to be able to put the same keyframe we put on the AOS fractal, but it has to be not in the OAS offset animation sequence. So how can we do that? Well, let's copy our value here, and what we're gonna do is simply we're gonna replace our automatically generated line here by the same thing, but which would be created by a light instead. So we can create geometry with a TAO light. We're gonna put down the same value as those. So let's go ahead and create a new light. Control-Alt-Shift-L. Let's call it TAO, and let's make sure that it is a spotlight. Let's try to keep down the default value here. The radius should be 100. If not, you can change it back here. Set it to 100, and by default we're gonna get a second piece here. What we're gonna do actually is simply reveal our position. So I've hit P, and let's make a keyframe on frame 0 and a keyframe on frame 300. And on frame 0 we want to put the same values that we have on line point 1, so 540, 387 and a 0 there. And for the last frame, we want to put down what we have in line point 2. So 540 minus 90 and 0. Alright, so now we're back at what we have with the path generator, except that we're generating with the light. So let me turn that off. And one thing that we also forgot about when we use light, like we most often always do, hit Control Alt O on the light and set the auto orientation to off. So this should set it back like it should. So now we're back to something like that. I hope it's not too confusing. But now we're not. Now what we can do is pick up the frames from our OAS fractal here, and we were starting at frame 66. So let's shut this down and let's leave it at 100 right there. And let me explain something to you that you might not know. So in the paths from TAO light, there's this option here, fractal amp from fall off distance, and this is exactly what we're gonna use. So we're gonna check this off, and I think that I had some random weird value here, 500, yeah. So at 100, it should be full amplitude of the fractal, and if I set that to 0, it shouldn't be. So this is where we can keyframe it. Let's hit Control V because I've copied to the clipboard what I had in the fractal. So this is going to be our fractal AOS now. So this is interesting because now that it's not stuck in the AOS offset animation sequence, now we're able to play around and keyframe the offset value without it interfering with our OAS fractal. So do we still have a loop in there? Let's just shut down our fractal just to verify we're dealing with here. And why is it not behaving like it should? So what we're gonna do exactly now to have it loop and not interfere with the fractal OAS or the fractal over time, we're simply gonna uncheck the size, simply because we're not animating the size, and we should get it right now. So we've got our animation, we've got our OAS still active, but it's not controlling the OS fractal. It's just controlling the position X that we are having control with the frequency, and now our fractal is looping, and our the fractal amp from fall off distance is controlling exactly where we're pinching the fractal, where we want it not to occur and where we want it to occur. So they are not displacing as we are near the center, and now our keyframe are on the light, and the light is doing exactly what the automatically generated path was doing, but now it's keyframeable, and we can get away with animating the offset here from 0 to 20 without it moving our actual OAS like it would if we would have done it in the offset animation sequence. So a little bit tricky stuff here, but that's why I kept it for the end. And yeah, now you have control on this. You have control on everything. We can set back the reflection, our custom reflection here. Ah, much nicer, but it seemed more bright. It seemed more bright. Maybe we can get back in the reflection here and correct that by going like this. Maybe it's not as dark as I think it is. So let's see how. It looks a little bit better anyways. Let's really increase that. Let's put the levels there. And let's just crunch those, make it dark, and let's have it really contrasty. And let's see what kind of a result that we have here once it's done refreshing. Come on, come on. Ah, much closer to what we would want. Not perfect yet, but I think with the blur we can control it a little bit more how it looks if we compare it to the default pre-built. It definitely looks better. So I hope that you enjoy. This is going to be all for today. If you have any further questions, don't hesitate to ask. If you have any ideas about one of my dailies that you would like me to decorticate and explain exactly how it was done, you know what to do. Send me a little tweet or a little message on Tumblr, or I've got many more tutorials for you to enjoy, and I will get many more in the future. So as always, thank you very much for watching, and see you next time.